In this video, we'll talk about rational exponents, what they mean, and how to convert. So before we get too crazy into talking about what a rational exponent looks like, let's review what a rational number is. So a rational number, recall that there are two working definitions. One is that it's either a terminating or repeating decimal, or the definition I prefer, it's a fraction involving only integers. So x is a rational number if it can be written as x equals a over b, where a and b are members of the integers, meaning they are a whole number, 0, or a negative whole number. And we're also assuming here that b is not 0, because when I divide by 0, weird stuff happens. So the idea is I have something like this. X to the power of, let's say, 2/5. What does that mean? That's what we're talking about today. What do I do when my exponent is a fraction? So let's talk about that. So let's think for a second. We know that if we have x squared and we take the square root of that, well, we get x if we neglect the negative half of the curve, which for the most part we do when we're talking about functions. So let's also think about it this way. X to the power of 2 to the power of 1/2 would equal x to the power of 2 times a half, which is just x. Meaning that if I take the square root of something, that's going to be the same as if I take it to the 1/2 power. These two things, these two expressions are equivalent. And likewise, a cube root is to the 1/3 power. A fourth root is to the 1/4 power, so on and so forth in that fashion. So this denominator of my fraction, if I have an exponent, that's actually telling me, hey, that's whatever root you're taking. So let's put this into practice. Some of the power of being able to convert here really helps when you're trying to simplify expressions. Sometimes it's easier to simplify them as a radical, and sometimes it's easier to simplify them as an exponent. It really kind of depends, and that's the skill that we're trying to build here. So if I'm looking at x to the 4/5, what this is telling me is, hey, this is your root. You're taking a fifth root. And then whatever's left, that's what's going to go underneath your radical. So ultimately, you're going to have the fifth root of x to the 4th. Full stop. That's all it is. Now, later we'll talk about, okay, we can simplify this, we can reduce it, those kind of things. But for now, we're just making the conversion. Now let's go the other way with it. Some of the power is taking a radical expression and rewriting it as an exponential expression. So we can, again, look at this power, so to speak, the root number. And we know that this is going to go underneath as a denominator, and then I get rid of the radical. So this is going to be the same as z to the power of 4/7. Full stop. Now again, it can be useful depending on what you're doing if you're trying to simplify these things. If you have, for example, the 7th root of z to the 4th times the cube root of z to the 5th, well, it can be a lot easier to convert this as an exponential and then just multiply the fractions, or add the fractions rather, in this case. So there's one example as to where it might be useful if you're trying to simplify expressions. Make it to where you have z to 1 power, or even if you wanted to convert it back so that you only have one radical expression once you're done.